In this video, we'll take a look at an ATS digital service system that supports resource tracking and metrics to an organization by utilizing an event-driven architecture. This demonstration will look at a use case that is initiated when a work order is submitted into an IT service management system. In this case, a simple ITSM is used, but this application is easily integrated with other systems like Remedy, Salesforce, or any other system that is API addressable or capable of streaming data. The application will use information such as preferred technicians and GPS location data to determine which technician to assign to a work order. It will manage all interactions with the related service management system to ensure timely resolution of the work order, and it will use a mobile application in which to notify service technicians of the work order and communicate context of the assigned item. The system is also able to track various performance levels and provide alerts and reports when various thresholds are crossed. So let's take a closer look at our resource tracking application. The first thing we'll do is create a new user account for use on our application via a mobile device. I'll click here on Add a Technician, and we'll fill out the details for the user. A unique username, a first name and last name, the user's phone number and email address, and then we'll set a default password. Finally, we'll click on Submit to add the user to the system. A confirmation dialog lets us know the user was successfully added. If we now move to View Technicians, we see our new user in the list, but the user does not appear on the map and is not yet available for work. However, now that this user exists, we can open our mobile application. Once authenticated into the platform, we'll set our status to Available by choosing the Technician login screen and selecting the Login button. Back in the web UI, we see that our user is marked as available and their location appears on the map. Our technician is ready to accept service calls. Moving to our simple IT service management system, which again could be Remedy or any other IT service help desk system, we'll create a new work order. On the right, I'll select one of our open incidents and associate the incident with this work order. I'll add a description to the work order and set some values such as the asset category, the asset type, and a desired SLA response time. The address has been filled in automatically as well, but our user is remote, so we'll override the address with his correct location. In this demonstration, the schedule date will be set to the current time, so we'll be immediately dispatching the technician to the site. Finally, we submit the work order. Since the service management system only records a written address, our application is integrated with the Google API to turn the named address into GPS coordinates. Once the work order is entered, APIs open an associated record in our application to start the collaborative aspects of dealing with the newly entered work order. Our application uses a recommendation engine to find a technician or technicians to handle the work order and uses information like geolocation as well as other attributes to identify the proper service tech. We see on our mobile device a notification has been sent to the user. By clicking on the notification, I'm brought into the mobile application and to the Notifications tab. Selecting the notification opens up additional detail useful for our tech. The notification provides some simple details about the work order such as the SLA response time, the category, and location of the item. The system keeps track of when the notification was sent and when the user accepts it. By setting escalation parameters, if a user doesn't respond in the desired amount of time, a notification can be sent to a manager for further review. Our technician will choose Accept to acknowledge the work order assignment. This also sends API calls back to the integrated service management system so that the system of record has up-to-the-moment details regarding the ticket. Now that the work order has been accepted and therefore assigned to our user, the system immediately responds with the work order detail. Opening up this notification, we see more pertinent information like the company and customer, the details of the assignment, as well as a map showing the location where the work order needs to take place. The system will automatically track the user's location throughout the journey, updating visualizations such as our map, and send a completion form automatically upon arrival. If GPS data is unavailable, then our technician can manually trigger their arrival by pressing the Arrived button. However, in our example, GPS is enabled and our technician is already on site, so the arrival happens immediately and we get the work order completion form. When our technician is done servicing the customer, He indicates that the job is finished by selecting the Complete Assignment button. The technician's notes and any relevant data like arrival time and completion time can be automatically placed back in the integrated IT service management system. Now that you've seen the collaborative integrations between people, mobile devices, and systems, let's look at some of the reporting, data, and metrics. Using the information collected from the work orders and from the technician's responses, we can build visualizations in the form of graphs and dashboards that will show the performance of individual assets and technicians. Perhaps more importantly, we can also determine the level of service being offered to our customers using these graphs that can show if we are meeting our service level agreement goals or not. The first report we'll look at is our SLA report. This report contains two different pie charts whose purpose is to show for both open and completed work orders how many have not satisfied the SLA by customer. The open work orders at the top serves as a red flag indicator that a customer may potentially have multiple work orders that are going to fall outside of the defined service level agreements, while the completed chart below provides a historical record of the SLA performance for a given customer. Next, we'll look at escalations. This report provides a view of all currently open work orders that have been escalated because a tech has not responded to a work order request in a timely manner or has not arrived at the job site at the scheduled time. These escalations allow a supervisor to determine if remedial actions need to be made to ensure the customer SLA demands are met, or at the very least, provide updated information to a customer and inform them of any delays that technician may experience while trying to get to the job site. This can improve customer satisfaction by setting proper expectations even when things don't go exactly as planned. The priority tasks view is a graph and table combination, which will show a count of all the currently in-progress work orders that have fallen outside of the stated service level agreements. While the graph on the top gives us a quick view of how many items there are, the table below will show details about each of the work orders. This allows us to identify all the work orders in the system which are not meeting our goals. The data in these charts comes from real-time sources, and this information allows ATS to respond quickly to problems, which will lead to both improved response times and improved customer service. The application can also monitor aspects of the technician's performance. In this report, we are viewing the individual technician's performance by product model. Graphs such as this one can call out different warning indicators. For example, if one technician consistently has a longer response time than others, or takes far longer to complete work orders compared to his peers on the same products, this could indicate an insufficient skill set or a need for additional training. Conversely, it provides a way to identify top-performing technicians and can be used to provide a means for tracking incentive programs for those top performers. On this last report called Assets, we are looking to identify performance indicators for individual product models, categories of products, and customers. For example, the bar chart at the top is showing the average amount of time it takes a field technician to resolve issues associated with the given model. The pie chart on the left allows us to see how many work orders have been raised by each company, enabling us to see which customers have required the most on-site tech visits. The middle pie chart is showing which category of products generate the most work order requests, and the chart on the right is showing the number of work items generated by product model. These reports allow us to identify who or what is generating the most demand for on-site tech service and allow us to investigate new ways to reduce those numbers and staff resources appropriately based on current and expected demand. For example, if we look at the middle pie chart, which shows the number of work orders by category, and at the bar chart below that is displaying the technician time required on average to resolve work orders for those categories, it shows us that while laptops generate the most work orders, they take the least effort to complete, whereas the storage servers generate the least number of work orders but take the greatest effort to resolve. This allows us to more accurately set SLA expectations and to set staffing appropriately to meet customer demand. Thanks for taking the time to watch this video.